Alright, 7.1, we're going to be graphing exponential growth functions. The objective, students will be able to explain that the parent function for exponentials is f of x equals b to x. In other words, it's this. You notice where x is in the exponent, or b is greater than 1. So b here is greater than 1, and x is now in the exponent. That's why it's called exponential. Now, since b is greater than 1, that makes it a growth function. What makes it exponential is the variable is located in the exponent, and when this number b is greater than 1, now first of all it's positive and greater than 1, so it'll be 1 or 1.1 and so on, you have a growth. Also, students will be able to determine the horizontal asymptote of an exponential function when looking at its graph. Right? That's what we're going to talk about right now. What is a horizontal asymptote? Alright, horizontal asymptote. Alright. The horizontal asymptote is the x-axis. In this case, for this function right here, the parent function, this is called the parent function, because all exponential functions are based off of this. You notice the x-axis right here, in this case, is also now called the horizontal asymptote, HA. What that means is this: as x, right, as I am going this way, and I'm going to negative infinity. Negative means I'm going left. Infinity means I'm going on forever. So if I go this way and keep going on forever, the graph, you notice this graph keeps getting closer and closer to the x-axis. But it will never cross it or touch it in any way. Alright? Now it looks like it will, but it really doesn't. You can pick any value you want for x. It will never ever touch the x-axis. Never. Alright? That you have to take upon faith. It's proven mathematically, but if this is your first time looking at this, it could probably blow your mind. Alright? You just have to accept it, and as you continue on in this lesson and future lessons, you'll understand a little bit more and more and more about why that does. Alright? Alright, so exponential growth. Exponential means that x is in the exponent. This b has to be greater than 1. Now what is this a for? Well, a is your y-intercept. Alright, see here, so no matter whatever a is, that's your y-intercept. That's the point where it crosses the y-axis. So that's where a comes from. Alright, so what we're going to do now is we're going to graph some of these. Right? So first thing I want to do is, first of all, is b greater than 1? b is 4, so yes, so this is a growth function. It's exponential because x is in the exponent. Now I want to graph it. Well, what's a? What's in front? What's assumed to be in front here? It's 1. So your a is 1, so it crosses the y-axis at 1. So that's the first thing I do. Put 1, it's right here, put a point. Now I just want two other points. I want one point on this side of the y-axis and then one point on this side of the y-axis. And then I'll sketch my curve. Alright? So make a little t-table. Alright, let's pick one point past the y-axis. So let's pick 1. So now x is 1. So I put 1 in for x. So 4 to the first power gives me 4. So 1, let's see, this is 1, 2, 3, 4. Put a point there. Alright, let's pick one point to the left of -1. So make this -1. So I got 4 to the -1. Remember, negative exponent gives me 1/4, so that is 0.25. So I go -1. So here's 1, here's 0.5, 0.25 is somewhere in here. All right. Now we plotted the points, now we sketch a curve. Now remember, since this is, excuse me, I had a little brain fart. What we're going to do here is, now you have to remember, my horizontal asymptote is the x-axis, so that means it cannot cross the x-axis or touch it. So when I sketch it, start somewhere close, and making sure it's a curve. And put arrows on both ends because it goes on to infinity in both directions. That's how you graph. All right, so let's review. First, I found out what A is. All right, I plotted it. It's my y-intercept. Then I do the little t-table. I pick one point. I pick a positive x value, and then I pick a negative x value. When you pick a negative, you're going to get a decimal. All right, just to let you know. You pick a nice number, you're going to get a nice number as well. Let's look at another example. All right, so first of all, is b greater than 1? B here is equal to 3, so that is greater than 1. So it's a growth function. My variable x is in the exponent, so it's exponential growth. All right. So what's this other number 1/2? Well, that's your A. So A is 1/2. So there's our first point that we found already. So here's 1, here's 1/2. 1, -1. So this is at 1/2. Make a t-table. Pick a value for x. Let's see, we'll pick 1. So I got 1/2 times 3 to the first power. So that's 3 to the first is 3. 3 times 1/2 is 3/2. In other words, is 1.5. So here's 1. Here's 1.5. Point there. I'm going to pick -1. Because that's a negative value. So I get 1/2 times 3 to the -1. So that's 1/2 times, this becomes 1/3, because a negative exponent means we take the reciprocal. So that gives me 1/6. All right, so this is 1/2, so 1/6 is even less, so we'll approximate it somewhere in here. All right, and now what I do is sketch my curve. Put arrows on both ends, and there you go. Last example. Excuse me. All right, so what happens if A is less than 0? All right, first of all, B is equal to 2. All right, because B is not equal to -2 because x goes with B. So remember, it's B to the x. If I wanted to include the negative, this would have been parentheses right here. But there's no parentheses there, so therefore, B is just 2. So 2 is greater than 1, so that's growth. Variable is in the exponent, so this is an exponential growth problem. So this negative means that's my A. Negative what? -1. So really, I can rewrite this equation that looks like this. Y equals -1 times 2 to the x. All right. So A is -1 and B is 2 to the x. A is -1, so there's my y-intercept. There's -1. All right. All right, now we pick 2 points, pick a positive value and a negative value for x. So I'll put -1, put 1 in, so I got -2 to the first. 2 to the first is 2, that gives me -2. So your answer will always be negative, all right? Because you got to do the exponent first. So if that makes it negative, positive, it doesn't matter, but then that will always make it negative. All right, so now I'll put negative 1. Oh, hang on, let's plot this. So it'll be 1, negative 2. Right there. Plug negative 1, so I got negative times 2 to the negative 1. So it's negative, well, 2 to the negative 1 is 1/2. So it's negative 0.5. Negative 0.5, negative 1, negative 0.5 is right there. Now again, your x-axis is still your horizontal asymptote, so I cannot touch it. So I'm going to put it somewhere close. And there's my exponential growth function. And you notice when a is less than 0, what this means right here means negative. A is negative. There's an easier way of saying a is negative. So if a is negative, you have a reflect across the x-axis. Because remember, it used to be something like this. All right, but now it's reflected over. In other words, I reflected it over. That's what a negative a does.